It's a pleasure getting to walk us through a very interesting project. So let me quickly show you the data set. So it has to do with employee attrition. So let's visualize the data set. So the data set that shows the age, business travel, daily rate, department, distance from home, education, education field, employee count, environmental satisfaction, gender, hourly rate, job involvement, job level, job role, down to we're trying to predict the attrition. So if you want to check the meaning of attrition, the process of reducing something's strength or effectiveness through sustained attack or pressure. So looking at these various behaviors of various employees, we can then so one here indicates a positive, and that's true. 0 indicates false. So based on what we're trying to predict for, which is attrition. Now, so from these data sets, so we can see, so from where I got this data set, this happens to be the train of the data set. It's for an ongoing competition, but I'm going to show you how you can do it in a very simplified manner using Autogon AI. So we can see the train has 1,677 rows. Let's try to visualize this data set. Let's visualize the data set. Let's see if we can pull out a heat map and as many more charts to understand the relationship between columns, properties of the data set, leveraging the power of Autogon AI. Let's give this some seconds. Oh, voila. So we have a heat map. And so we can already see the levels based on their colors. The correlation between each of the columns on the data set. This already tells you some interesting stuff. I don't want to dive into data science. So this is just going to be high level, percentage strike, years of experience, age, do some visualization, and we can always download them of this chart. Carve out plot, we'll be doing some comparison, direct manual comparison between columns. So if we're looking at distance from home and attrition, so we can see distance from home and attrition. So you can see the positive attrition, they have more distance from home. So people who stay away more from home tend to get tired of their job. So let's look at age and attrition. Oh, you can see the higher the age, the tendency for them to stay in the job. This is beautiful from the data set. Let's look at monthly income. Oh, we can see the higher the monthly income, the more they stay in the job. So this is very obvious, and I like this. This is quite obvious. Let's look at attrition as to years at the company. So the more the years, the less they stay. The more likely would they stay. So obviously, the guys who have stayed long are most likely sold out into the vision. So the CEO might be doing a very good job. Total working years, and same for this. So let's look at per scatter plot. So look at some little more relationship before we go straight into building the model. And let's give this some seconds while it loads up. can see the loading icon happening somewhere down here. And yeah, age, daily rates. So if we look at, let's say we want to work x-axis age and y-axis, so it's not bringing out the attrition for me. Um, age as to years at the company, uh, age as to hourly rate. Oh, this is not changing. Okay, total working. Okay, this is changing. Uh, let's go. Let's dive straight up into building the model. And okay, so on Autogon AI, you can build the model either leveraging. I've created the project already. You can build the model either going through the Studio Wizard tool, or you build the model either going through Studio. So LabelCraft on Autogon AI is used for building vision models. So we'll start by building for Studio Wizard. Studio Wizard is our AutoML environment for building models. So we launch this and select existing data sets, employee attrition, and let's give this some second white later. Keep cold water. Okay, so great. So from this data set, we can already see the level of importance for each of the column. So we can see the age has high amount of importance. Monthly income has high amount of importance as well, same as job level. Low percentage salary, high, low. And again, we can see years with current manager, years since last promotion, years in current role, and years at the company have high amount of percentage as well. So we can also look at the mean for each of those axes and the standard deviation. Yeah, so if I go next again, that's the classification problem from the data sets. Looking at the data sets, you see what we're trying to predict has to do with attrition, either a false or a true. So this is a classification problem. So we select classification, we select what we're trying to predict for, attrition, and we call this employee attrition, and we train. Let's give this some seconds. Okay, so we already have our model, and Autogon AutoML platform found to predict the target variable, which is attrition. Okay, and if we look at feature of importance, so we can see these guys with high importance, and how much they are likely to impact if a particular employee gets tired or not. So here we already have our model. Beautiful. And so the next thing we can do is, let's look at the accuracy. A simple way to calculate the accuracy. This is a confusion matrix. Calculate the sum of this divided by the sum total of every single thing. So we can say 4, 2, 9 plus 16. 4 to 9 plus 16 divided by 4 to 9 again plus 16 plus 44 plus 15 plus 44 plus 15. So great. We're already having an accuracy of 0.88. So by the time you do 0.88 times 100, so these are accuracy value. It's 8.2%, and this is a very good accuracy value. It's 8.2%. So from here right away, we can go ahead with conducting predictions already, and to interact with our model. One way to go about this, and also there are also APIs that has been built already off of this model that you can already interact with those APIs to hit your model as well. Now we're going to do something now. Let's create a sample data set. So if you see, we clicked on this particular project, we can already see employee attrition. I want us to create a sample prediction data set so we can test out our model. I created a test data off of the main data set. So if you visualize the data set we used to create the model, you see you have all of these columns. So this for index 4, and so this is the attrition prediction, which is positive down here. So I can copy all of these just before the attrition prediction. On Autogon, you can generate a data set under quick predict. Select the project, select the model, create data sets, and once you paste that, select one dimensional, and voila, you have the data set. And just to display it, yes, so this is data set. So if I come to this test data and I predict if this guy is going to be positive or negative, and yes, I can see the prediction is 0, and prediction attrition score is 0.8, and so here we can see it's 1 here. Oh yeah, so that's why the accuracy is 0.8. So if we take this other guy here, and we'll create a data set off of it, and generate data sets, copy the data sets, and we come to attrition prediction, and we run our prediction. So we can see it's a 0, and the model predicted this to be 0, and the prediction score is 0.935, and so we can see it's a 0, so the model is correct. So if we take column 6, that's row 6 rather, and generate a data set off of it just to test out the prediction, and we copy this and we're coming down here to test data set and paste it, and we quickly run a prediction, and we can see prediction label 0, and predicted it to be 0, and then it has a prediction score of 0.6316, and good, so the model is correct. So we can try this out just before this comma, line 532. So the model is predicting with an 88% accuracy, dimension 1, and we copy this data set. So this I'm using for the prediction. You can also predict using the API, and yeah, predicted this to be 0, and the prediction score is 0.7833. And is this correct? No, it's not correct. So let's check line 533, and let's generate a data set of it, dimension, generate, and we come down to test data set, paste it, and we do a prediction, and we can see the prediction score of 0.9539. Great. So let's create a pipeline, as simple as creating a pipeline, and we can always inference this model via the pipeline through our API. So the next phase we're going to do is, so we've built a model off of this data set using Studio Wizard. We are going to go about building a model off of this data set using Function Studio shortly. But before we do that, let's predict the test data that was provided to us by the competition. This is the test data set that was provided. This is the test data set that was provided. So let's pour this into this side to interact with our model, and yeah, and get our predictions for it. And great. So we can see various prediction, and this happened in few seconds. So what we're going to do next is to download the whitepad. We're going to download the whitepad shortly, and after downloading the whitepad, we can then send it back to the competition owners. Yeah, send it back to the competition owners. As simple as that. So yeah, so that's the end of using Studio Wizard. So you've created your pipeline. You can always inference your model using an API or go through Autogon SDK to inference your model. Just some minutes ago, we were able to build up employee attrition off of Autogon tool known as Autogon Studio Wizard, and we got an accuracy of 88%, which is a very good one. But yes, can it be improved? Yes, it can be improved. So I'm going to come into Autogon product called Autogon Studio, and the beautiful thing about Studio is we're not going the AutoML route. We are actually going to be building up the model ourselves. So on Studio, if I drag data inputs, and the recent data set I added was employee attrition, and I come on to this, select the CSV, enter the CSV URL, I load up. Yes, successful, and I can already see the data set. Well, seeing these data sets, so there are two ways to go about it on Autogon Studio. So we can manually pre-process on Autogon Studio, and we can automatically pre-process all of these on Autogon Studio. But before we go about the entire process, columns like ID is not significant. We want to kick it out because the higher the value, the more it messes up our model. So we want to kick out columns like ID. So let's quickly look for a drop column. So a drop column feature on Autogon AI, and for the data set, drop column 0, and successful. We've just dropped column 0. Let's visualize this again. So we can see ID variable has been removed. So we can see column 1, column 3, column 6, column 9, 13, 15, and 19. They are not in formats that the algorithms are going to be building this model off of it. Great. The algorithms are going to be building this model off of it, understand? So we need to convert them into formats that these algorithms understand. So there are two ways we can go about this. We can go by manually doing this, which is work, and we can do this in an automated fashion. So for the sake of beginners, I would go the route of the automated fashion. So I don't scare beginners. So let's go the route of the automated fashion. So Autogon has this automated data pre-processing. Automated data pre-processing. So connect this automated data processing to the drop column. That's the result of the drop column. All our variables is being stored in this region. So now we've connected it. Then we would split the data sets. So you need to get used to slicing. You can go read out Autogon documentation on slicing. So colon, comma, colon -1 is going to fetch all columns and all rows except the last column, and column -1 will fetch just for the last column but all rows. Strategy value for missing rows, and we'll just use mean. Test size. We can use a 0.2 here for our test size. Label and code threshold, I'll leave this to default, and I'll save this ADP_ model, and just put it like that, and I run this automated data preprocessing, and it does all of the preprocessing. One hot encoding, label encoding. I can specify columns to exclude if I don't want them to be encoded as well. So let's come visualize. You can see it has handled the splitting already. Now this is the raw data set, and now this is the X value. So now this is the X value, and you can see travel has been splitted, human resources has been splitted, and sales and column 5 was splitted as well. So manager, manufacturing, blah blah blah. So automated data processing has handled all of this splitting for us. But I kind of have a challenge with this. It splitted columns, I don't want it to split, so we would have to rerun this. Okay, let's check out the y value first before we run this. Oh yeah, it spit out the attrition, which is fine, but there are columns I wanted to ignore. I wanted to ignore all of these columns from column 21, all of this. So from column 21 down to column 32, I want it to be ignored. That's number one. Number two, so let's look at the parameters again, what it accepts, and see how we can play with it. Excluded column, so we would have to manually type out all the columns we want to be excluded. Exclude columns from missing data, exclude columns from encoding. So yes, exclude columns from encoding is what we should be after. Column from encoding. So column 2, column 4, column 5, column 7, 8, 10, 11, 12. So we would have to draw out a sheet for this. So we can type out columns we need to exclude. Or we build this manually. So column 2, 2, 4, 5, 7, 8, 10, 11, 12. 2, 4, 5, 7, 8, 10, 11, 12. 7, 8, 10, 11, 12. 14, 16, 17, 18. 14, 16, 17, 18. 18. 21, 22, 23, 24, 21, 22, 23, 24, 25, 26, 27, so 25 to 32, 25, 26, 27, 28, 29, 30, 31, 32. So I wanted to exclude all of these columns. So I think I'm also going to show you guys how to do this preprocessing manually. Okay, yeah. So let's review X values again. And yes, it excluded those columns. And so this works. This works. Okay. Now, let's also look at Y values. Yeah, so this is fine. Just to be sure one more time. Okay. So this works. So the next thing we'll now need to do is to feature scale. So we can use the min-max scaler. We need to bring in feature scaling. I think I should just keep this one side, so I can also show us how to do the manual automated manual data preprocessing. So feature scaling is a feature. You want to keep all columns. You want to keep all columns well sized, so some are not having higher variables than others. So we're going to be scaling the X string and the X tests, and we're going to use the min max scaler, and we're going to scale every component, and we'll save this as fs feature scaling underscore m, and great. So let's quickly view what has been scaled. So this is the X value. So something seems to be wrong. So okay, I did X value, X string. Great. So you can see we've scaled every single item to ones and zeros. So let's look at the S test as well. And great, we've also scaled down X test to ones and zeros. Okay, so we're going to use multiple algorithms. One of the algorithms we're going to use is a random forest classification. We'll try out the random forest. So why I like the random forest, the XG boosts and decision tree, those guys, is because these models are called ensemble models. Random forest classification, and so ensemble models. Don't read on example models. So random forests, RDF, random forest, and we can use criteria of Gini. We leave it as default, and we run the random forest classification. We can also bring random forest classification metrics. It's also see the metrics, and random forest classification predicts. So yeah, so the predictor is going to be called after the metrics. So we run this. For the predict, so we want to predict the X test that was generated off of the model. So we leave this as default. So the default predicts the X test data, and great. So we enter the model name here again to check what accuracy random forest classification is giving us. And you guys are interested to see? Let's try 0.85. Oh, pretty interesting. Oh, random forest give us an interesting accuracy. We're going to try out a couple of more models to see which comes out the best, and also some deep learning models as well. So I want to try the XG boost. Let's see what XG boost is going to give. XG boost predict and XG boost metrics, and so connecting all of this together. So XG boost. So let's run our XG boosts and let's see what XG boost is going to do. Let's go. Okay. XG boost predict, and XG boost metrics. Are you excited and wanting to see? Voila! Boom! So, XGBoost actually also came up with a very pretty interesting accuracy of 0.88. So, Studio Wizard gave us a model of 0.8. So I want us to look for something that's going to beat Studio Wizard. And also, just so you know, so there's automated machine learning. That's the beautiful thing about Autogon AI. So we kept on dragging machine learning algorithms one at a time, but you can go the automated machine learning route to do this. So let's drag one more algorithm, and that's going to be decision tree. So I'm interested in knowing what decision tree can do for us. Decision tree predicts and decision tree metrics. So decision tree classification, decision tree predicts, and decision tree metrics. Okay, so let's give this some space, and so decision DSC, this is fine to me, and random state, we keep this on 0, and we run this, and come here, insert the model name, default. So the default for Autogon AI is actually the test data set. And come here again, enter the model name, and we run this, and I can't wait to see what decision tree is going to give us actually. Decision tree, here you go. Oh, the random forest and XGBoost outperformed decision tree. Okay, so we can come down to automated classification. You can see classification automated here. So this guy. So we can bring in this guy, and also bring in this guy predicts, and also bring in this guy metrics. So we can run as many algorithms as possible instead of dragging them one at a time. So that's the beautiful thing about Autogon AI. You can achieve a high accuracy in a jiffy, playing with multiple algorithms. Oh, how many seconds do I want this guy to run? So I'll do 120 seconds, and rate limit for each algorithm run for 20 seconds, and model name, and give me automated ML, and run for me. So we have to wait about 120 seconds, except it's done before then. And when we are done with going the machine learning route, we'll actually test out building some deep learning models. So it's either we build these deep learning models manually, or building an ANN network, or we build an automated deep learning. So I think we should just do the automated deep learning without taking much time. But yes, you can build an ANN here after you drag the sequential artificial intelligence in it. And so we're having to do with a train, ANN train, and when you're done, evaluate, then predict. But the beautiful thing about going the automated deep learning route is it tests out different parameters for you automatically. So that's the thing about AutoML. So Yeah, Autogon AI is a very beautiful suite. We've crafted for both novice and professionals. So to building high-end models. So you can see what we're able to go through the route of Studio Wizard to build and obtain an 88% accuracy. And you can see we came through the studio route to try out stuff ourselves, and yeah, well, we've gotten some algorithms that is also operating at that same frequency as well. Oh, it's actually a beautiful evening. Currently at Lagos, Nigeria. Uh, yeah, even as we attempt to solve some interesting problems. Okay, great. Uh, so it took a while. So that's the thing about running the automated classification learning algorithm. It just comes through a whole lot. So let's test out um, and see what accuracy we're getting out of this, and also so we can see the sprint statistics. So I'm very much interested in. Oh, it ran about 49 algorithms. Best accuracy score was 0.88.2. Yeah, and yeah, and so let's look at the leaderboard. And oh, an example model came out the best. Gradient boosting, and so entering the same item here. We can get metrics as well, and yeah, 0.88. So we've actually tried out a lot of algorithms on the machine learning side. So let's be hopeful. Let's be hopeful. Let's try out stuff on the deep learning. So let's just go straight to the automated deep learning. Automated deep learning for structured data initialization, for structured data train, and for structured data evaluate, then predict. Oh no, deep learning train, auto structured data. Oh yeah, this is classifier. So that's correct. Auto structured data classifier. Classifier is for regressor. So let's drag from this feature scaling down to this guy, max trials. We can leave it 10 or keep it at 5, max trials of 5, and then we run the init. Number of epochs, we can leave number of epochs to be 10, and call this automated structure the classifier I. I'll just put M, that's the name of the model we're wanting to create, but you have to ensure you connect it to this block, and we run this, and this is going to build a neural network for us. And when we are done, we evaluate the neural network and we run some predictions, and let's see if we're able to beat 0.88. But some interesting things you want to do if you're wanting to beat 0.88, you want to do some interesting feature engineering. So one, increase the number of data samples. Two, do some interesting feature engineering, denoise the data set. So denoising the data sets is going to help improve the accuracy, but we're not going to be discussing that here. But if we denoise that data set, we'll greatly improve on the accuracy. So let's have this guy fully run, and then we evaluate and we make some predictions. Of course, we're very considerate. Yeah. Okay, so let's evaluate our neural network. I have to keep batch size 10. Then when we're done, we'll predict the X test. And okay, so we have an extra 0.1 accuracy off of the neural network. So yeah, the neural network route actually wins. So let's run a prediction. So just to be sure I'm not making a mistake here. Okay, so the predict is meant to connect actually to the train, and we can then look at the Y pred, and this is beautiful. This is beautiful, and this is good enough to submit your Y pred value back to the competition owner. And yeah, interestingly, we can build a pipeline if you want to interact with this via your API. All we need to do is we used drop column at 0. After drop column, we used the automated data preprocessing, and we used feature scaling at all boundaries. So drop column, automated data processing, and feature scaling. So if I come to this feature and create a pipeline, and I call it pipe ID underscore ID underscore, leave it as pipe underscore ID. Let's go simple. So I drag, I place the drop column at 0. The next was automated data preprocessing. So pipeline helps you handle all your necessary preprocessing on X, and I'll drag feature scaling. I drag feature scaling, and feature scaling we did for all boundaries, and here's the feature scaling weights, and I run save. So the run save takes it one at a time. It runs this, it runs this, and it runs this. One more item I needed to add to my pipeline was a model predict. Here we then specify which of the models we want to use. So this guy gave us the highest value, and yeah, we can run save of this. Oh shit! I just saved it. This one save just runs every single thing. How many cold water? Cold water. Yes. Okay. So this ran successfully. I can then come out with the switcher, and we're ready to interact with our data set. So if you come to this, all of the predicts, if you go through pipeline, now you can then see a pipeline ID. So this pipeline ID was one we created here. This employee attrition pipeline was the one we generated automatically off of the Wizard Studio. And take it.